Solving one-step equations. What is an equation? I like to think of an equation as a balance scale. Whatever we do to one side of our scale, we want to balance out on the other side. Here, we can represent a positive integer with a blue weight, and we can represent a negative integer with a red balloon. What do you notice happens when I put a weight onto my scales? Hopefully you notice that the weight pulls the side of the scale down, and the equation is no longer balanced. To keep it balanced, I could add a weight to the other side. What do you notice happens when I put a balloon onto my scales? When I add a negative number to my scales, notice that it moves in the opposite direction. The balloon pulls this side of the scale up. So to keep this balanced, I can add a balloon to the other side. What do you think happens when we interact a weight and a balloon? When we have a positive and a negative number, they're going to cancel out to get 0. So to keep this balanced, I can also cancel out the other side. What is an unknown? We can represent an unknown with this x tile. An x tile can represent a certain number of balloons or weights. In order to figure out what x is, I want to put the same amount of weights on the other side. So let's go ahead and add weights to the other side until we see what balances x out. So it looks like it takes 3 weights to balance out x, so x weighs the same as 3. When solving for x, we want to get x by itself so we can see what it weighs to, while making sure that the scales stay balanced. Problem 1. X plus 2 equals 6. Here on the left side we have our x accompanied with 2 weights, and on the other side we have 6 weights. In order to solve for x to figure out what x weighs, I want to get x by itself, so I'm going to remove these 2 weights next to it. That's equivalent to subtracting 2 on the left side, leaving us with just x. Hopefully you notice that the scales are no longer balanced, so to keep it balanced, I also need to remove 2 weights on the other side. That's the same as subtracting 2, leaving us with 4 weights on the other side. Since x is by itself, I know that one x tile weighs the same as 4, so x equals 4. Whenever x is being added to, I could subtract in order to get x by itself. Problem 2. X minus 4 equals 1. On the left side, we have our x tile with 4 balloons, and on the other side, we have 1 weight. In order to get x by itself, I want to cancel out all of these balloons. So to cancel out 4 negatives, I'm going to add 4 weights to the side. That's equivalent to adding plus 4 to this side, leaving me with just x. Right now the scales are no longer balanced, so I need to add 4 weights to the other side to keep it balanced. That's equivalent to adding plus 4 to this side, leaving me with a total of 5. Since x is now by itself, I know that x weighs exactly the same as 5 weights. Whenever x is being subtracted from, I can add in order to get x by itself. Problem 3. We have a fourth of an x, or x divided by 4, equals negative 2. Notice that we don't have a complete x here. We only have a fraction of an x. We have 1/4 of an x. That currently weighs the same as 2 red balloons. In order to solve for x, I want to figure out what one complete x would be. So let's go ahead and double the amount of tiles we have. Right, if I multiply by 2, I get 2 equal halves. In order to keep it balanced, I also need to double the amount on the other side. We don't have a full x yet, so let's go ahead and add another fraction. Let's go and triple the amount we have. But if I add another tile, I'm also going to need 2 more balloons to balance it out. And let's go ahead and complete our x. We need 4 parts to get 1 full x. So I need 4 times the amount of balloons on the other side. So how do we solve a problem when we have a fraction of an x, when x is being divided? I want to multiply, I want 4 equal parts in order to complete my whole x. I'm multiplying this left side by 4. And if I'm multiplying this side by 4, notice that I need 4 times as many balloons in order to balance it out. I'm multiplying this side by times 4. So I'll know that one complete x, one whole x, weighs the same as negative 8 balloons. Whenever we have a fraction over an x, or x being divided, I can multiply to get one whole x. Problem 4, 3x equals 9. Here we have multiple x's on one side of our scale, and we have 9 weights on the other side. How can we figure out what one x weighs? To do that, we can split up our scales into sections. So let's go and divide x into its own section. Since we have 3 of them, we can sort them into 3 equal groups. But whatever we do to one side, we can do to the other side. So let's go and sort these into 3 equal groups. Notice that now that we sorted both sides into equal size groups, I see that in one section, this x weighs the same as 3 weights. So how can we solve when we have multiple x's? What we're going to do is we're going to divide, we're going to sort them out into 3 equal groups in order to get what one x weighs. But whatever we do to the one side, we have to do to the other. We're sorting these 9 tiles into 3 groups to get one group of 3. Whenever I have multiple x's, when x is being multiplied by 3, I can divide both sides in order to solve for x. When solving for equations, remember that our goal is to get x by itself while making sure the scales stay balanced.